Function 3, one-to-one function or an injective function. So a one-to-one function is called an injective function. Now a function f such that x in the domain, such a domain element x is mapped onto the codomain elements y is called a one-to-one function if and only if every element of y is mapped onto one and only one element of x. So a function is one to one if every element of y, or if every element in the codomain y is mapped onto only one element in the domain x. Now a one-to-one function is called an injective function. All right. So maybe we can have a little illustration in the space that we have here. Um, if let's say for argument's sake, for example, if for example you have, let's say, just do a little illustration here. Here's a function. Now this is domain and this is codomain. Now in this illustration, every element of y is mapped onto only one element of x. So this function would be 1 to 1 or injective. All right, it must be every element of y is mapped onto one element of x. So I'm guessing that maybe a function that looks something like this. We have 1, 2, 3, 1, 2, and let's say you have something going like that and something going like that. I'm guessing that this would not be one to one because you have an element in y that is not mapped onto any element in x. So I'm guessing that this is not 1 to 1. All right, because the definition says that a function is one to one when every element of y is mapped onto one and only one element of x. All right, so let's move on. Now, to prove that function is one to one, we show that if x is if f of a is equal to f of b, then a is equal to b. All right, so if f of a is equal to f of b, then a must be equal to b. Another way is that we can sketch a graph of y is equal to f of x and draw a line parallel to the x-axis. So if the line is parallel to the x-axis, it's going to be a horizontal line. Then f of x is one to one if the line cuts the graph only once. F of x is one to one if the line cuts the graph only once. And I'm guessing that this must be every horizontal line that can be drawn must cut this graph only once. All right, let's have a look at example 9. In example 9, we're asked to show that f of x is equal to 2x plus 1 is 1 to 1. F of x is equal to 2x plus 1 is 1 to 1. Well, let's have a look at method 1. Method 1 says if f of a is equal to f of b, therefore, or then, a must be equal to b. If this is true, then the function is one to one. Now let's find f of x is equal to 2x plus 1. So f of a would be equal to 2a plus 1, and f of b would be equal to 2b plus 1. Now, if f of a is equal to f of b, then what we're going to have is that 2a plus 1 is equal to 2b plus 1. So therefore, 2a is equal to 2b plus 1 minus 1. So 2a is equal to 2b. If we divide both sides by 2, we would see that a is equal to b. So if it is that f of a is equal to f of b, if f of a is equal to f of b and a turns out to be equal to b, we can say that the function is one-to-one or injective. Therefore, f of x is equal to 2x plus 1 is 1 to 1 or is injective. All right, let's have a look at method 2. Method 2 says that we have to draw a sketch of the graph. And when we draw a sketch of the graph, every horizontal line that we can draw through the graph must cut the graph only once. All right, so we have what? Let's see, f of x, so this is method 2, is equal to 2x plus 1. Um, we could say y is equal to 2x plus 1. All right, so this is a linear graph. It's a linear equation, and the graph of the linear equation is a straight line. Um, the y-intercept is 1, and the gradient is positive 2. All right, so I'm just doing a sketch. So I have my y-axis, I have the horizontal axis. This graph cuts the y-axis at 1. So here is 1. This is my y-axis. This is the x-axis. All right, I could find the x-intercept. The x-intercept would be when y is 0. So we have what? 0 is equal to 2x plus 1. So minus 1 is equal to 2x. And then therefore divide both sides by 2. We get x is equal to minus a half. All right. So if this is 1 minus 1, the x-intercept would be where x is minus a half. So that's x-intercept. And this is the y-intercept. I'll draw a straight line through those 2 points. Now this is the graph of y is equal to 2x plus 1. And it is clear that we can see that every single possible line that I can draw parallel to the x-axis would cut this graph only once. Let's draw one of them. All right. Notice that this line cuts the graph only once. Therefore, again, f of x, which is equal to 2x plus 1, is injective, which is the same as saying is 1 to 1. All right, next question. All right, this is example 10. In example 10, we're asked to show that f of x is equal to 2x plus 1 over 3x minus 2 is 1 to 1. Let's use both, well, let's use the calculation method. Here, f of a would be equal to 2a plus 1 divided by 3a minus 2. Now, f of b would be 2b plus 1 over 3b minus 2. Now if f of A is equal to f of B, what we will have is 2A plus 1 over 3A minus 2 would be equal to 2B plus 1 over 3B minus 2. Now, if one fraction is equal to one fraction, what we should do is we should cross multiply. So let's cross multiply. Let's go that. So we have what 3A minus 2 multiplied by 2B plus 1 would be equal to 2A plus 1 multiplied by 3B minus 2. All right, let's expand. If we expand, we're going to get that times that. We get 6AB, that times that, plus 3A minus 4B minus 2 is equal to 6AB minus 4A plus 3B minus 2. All right. We can see that if I bring over 6AB over here, or the 6AB and the 6AB on both sides, the minus 2 and the minus 2, those go. Minus 2 come over and become plus 2. Minus 2 plus 2 is 0. 6AB minus 6AB is 0. So now we have 3A plus 4A is equal to 3B plus 4B. So 7A is equal to 7B. If we divide both sides by 7, we're going to get that A is equal to B. And we already stated that if f of A is equal to f of B, if f of A is equal to f of B and A turns out to be equal to B, it means therefore, so since f of A since um, since when f of A is equal to f of B, A is equal to B, f of x, which is equal to 2x plus 1 over 3x minus 2 is 1 to 1, or in other words, is injective. Next question. All right. This is example 11, and this is the last question in this section. Is f of x equal to x squared plus 2x plus 3 1 to 1? Let's try the calculation method. F of A would be equal to a squared plus 2a plus 3. F of B would be equal to b squared plus 2b plus 3. Now, if f of A is equal to f of B, let's see what happens. We're going to have a squared plus 2a plus 3 is equal to b squared plus 2b plus 3. The b 3 comes over, positive 3 comes over to the left hand side, it becomes negative 3. So that goes. So that goes. So what we have now is a squared minus b squared plus 2a plus 2b is equal to 0. Therefore, if we factorize, we're going to get a plus b, a minus b. That's a difference of two squares. And over here, 2 is common. We have 2a plus b. That's equal to 0. A plus b is common to both sides. So, oh, what an error. All right, this should be a minus here, in which case this should also be a minus here. All right, so minus here, minus here. So a minus b is common to both sides. So now we're going to have a minus b outside the bracket. Over here, we're left with a plus b. And over here, we're left with 2. And this is equal to 0. Therefore, a minus b is equal to 0, or a plus b plus 2 is equal to 0. Therefore, a is equal to b, or a is equal to minus 2 minus b. Therefore, um, f of x is equal to x squared plus 2x plus 3 is not 1-to-1, or is not injective. All right. We can also look at it from a graphical point of view. All right, and what I'm going to do is that I'm going to do a sketch of y is equal to x squared plus 2x plus 3. To do that, let me first find the minimum turning point. So I'm going to have to get it in this format. X squared plus 2x plus 3 is equal to a into x plus h square plus k. In other words, I have to complete the square. Using a formula, h is equal to b over 2a, and k is equal to 4ac minus b squared over 4a. H is therefore 2 over 2 times 1. H is 1. K is equal to um, K is equal to 4 times 1 times 3 minus 2 square all over 4 times 1. This is equal to 12 minus 4 over 4. This is equal to 8 over 4, which is 2. All right. Now, um, minus hk is the turning point. So minus 1 minus 1k, which is 2, is the minimum turning point. So a sketch of this graph could look like this. Y-axis, x-axis. The y-intercept is 3, minus 1, 2 is the minimum turning point. This is 1, 2, 3, minus 1. So I'm guessing my graph could look something like this. My parabola could look something like that. All right. Now, the theory says that if we draw a horizontal line, or every horizontal line that can be drawn through the graph must cut the graph only once. If it cuts it once, then it is what? 1 to 1. If there is a horizontal line that can be drawn that cut the graph what? 1, 2 times, it means that the function is what? Not 1 to 1. Therefore, as stated before, f of x is equal to x squared plus 2x plus 1 is not injective.